Okay, so I'm going to introduce you guys to the square root property method of quadratic equations. Okay, so for these things, you guys aren't used to seeing these yet. I don't think anyway. You may have seen these in earlier math classes, but I know my freshmen definitely haven't seen these. Let's see here. So now we are working with equations to the second power. Of course, anything to the second power is a quadratic term, hence the word quadratic equation. So when we're solving these things now, we're not going to get just one answer like we would when we were working with linear equations. We're going to get something like for this one. Well, first of all, I'm going to solve this thing for you, explain where everything's coming from, and then explain why we're getting more than one solution. So in this case, we're going to get two solutions to this equation. So first of all, well, when we're solving for x, we want to solve for just x. And in this case, we've got 1x squared. So in order to get rid of a power, in this case to the second power, in order to get rid of anything that's squared, we have to take the square root. So our next step here will be to take the square root of both sides. So that will come out to be x equals, let's see here, plus or minus 3. Okay, so notice now that I have both a plus and a minus sign in front of this 3. I'll show you the reason for that in just a second. So the proper way to write this is now going to be x equals 3 or x equals negative 3. So that will be the solution to this equation. Okay, so the reason that we're getting two solutions now, let me draw a little graph over here for us. I'm not going to graph this thing perfectly. I'm just going to give a little arbitrary parabola, which is what the things are called, the little horseshoe champagne glass looking graphs whenever we graph anything quadratic. And I'm going to show you guys what's going on here. So let's say that we have a parabola that looks something like this. I'm just going to call this f of x. Why not? Okay, so notice now that this parabola crosses the x-axis at two different points. So that's why we're getting two solutions, because we're basically looking for where the parabola crosses the x-axis. That's basically the general idea of what we're doing. And there will be instances when it doesn't, but we'll get to that later. Not even going to get there yet. But for the time being, that's what we're doing. We want to figure out where this particular parabola is crossing the x-axis. And of course, since it crosses here and here, we have to have two solutions. So now let's go on to another example. Let's see here. 3x squared equals 18. Okay, so this one's turned up just a little bit, nothing major. Okay, so for this one, well, obviously, we need to get rid of this 3 first. So we got 3 times x squared. Since we have multiplication, the opposite of multiplication is division. So we can divide both sides by 3. Cancels over here, which then leaves us with x squared equals 18 divided by 3 is 6. Now we can take the square root of both sides in order to get rid of that square. So remember, if we take the square root on this side, we have to on this side as well, which will then leave us with x equals plus or minus. You guys see that? There we go. The square root of 6, which can then be written as x equals the square root of 6 or x equals negative square root of 6. And those are our solutions. Okay, so I also need to show you guys a little bit about rationalization. And actually, I'm going to do that in my next example. But yeah, we definitely have to work on rationalizing, and that basically means simplifying radicals. That's anything with any kind of root symbol. So let's go on to our next example, which is, let's see here. Example number 4 now. So this one gets a little more messy. I'll show you why in just a second. You guys see that? Yep. Okay, so we are going to start this one out with 2x squared minus 7 equals 0. Okay, so naturally, we have to move everything away from x. So by doing so, our first step here will be, of course, to add x to both sides. So that'll give us 2x squared minus 7 plus 7 equals 0 plus 7. Now our 7's cancel on this side, which leaves us with 2x squared equals positive 7. So now we have 2x times x squared. So the opposite of multiplication is, of course, division. So that's going to be, it'll leave us with x squared equals 7 halves. Okay, so now we are going to take the square root of both sides, and in this case we have a fraction. And of course, as you guys probably already would have guessed, fractions call for a few more rules, of course. So now this is going to leave us with x equals plus or minus the square root of 7 halves. Okay, so for this thing, we're going to have to rationalize this. And yeah, I'll go over here in the margin or whatever you want to refer to this as and show you guys what's up here. So if we have something like the square root of 7 halves, I want you guys to start thinking of that as in the square root of 7 all over the square root of 2. Anytime that we have anything that's written like that, we're not allowed to have a radical in the denominator. So we can't have the square root, we can't have a root sign or anything like that down here at all, which that's referred to as a radical, of course. So what we have to do is we have to do this process called rationalization. So we have to rationalize here. But basically, we have to take what is in the denominator, which in this case is the square root of 2, and we have to conjugate, sorry, if I could speak English here today. We have to conjugate by multiplying by the square root of 2 over square root of 2. So basically, we're multiplying by some fancy 1, almost like we do whenever we are finding common denominators with fractions, except in this case, it's just kind of, I don't know, making everything look nicer. So now we're going to have, well, of course, when we multiply fractions, we go straight across the top, straight across the bottom. So that's going to give us square root of 7 times square root of 2 all over square root of 2 times square root of 2. Okay, so this is the exact same thing as this. Square root of 7 times 2 all over the square root of 2 times 2. I know this is tedious and ugly, and you guys are not going to like this. I'm sorry, just try to practice. And, yeah, okay, so now that's going to give us the square root of 14 all over the square root of 4. Okay, so now we want to look and see if we have any perfect squares. Well, 14 is not a perfect square, but how about 4? The square root of 4 just happens to be 2, correct? So now this thing can become the square root of 14 all over 2. Okay, so can we do anything else with this? Let's look at it here. So 14 times, let's see, nope. That is as good as we're going to get. So now this is going to become x equals square root of 14 all over 2, or x equals negative. Oh, I'm sorry, I'm going to have to bring that down here. Sorry, guys, I realized I was running out of room there. Negative square root of 14 all over 2. So this is our solution. I know that's a long process, and that's horrible, but yeah, you guys, with some practice, will get used to it. So try not to stress out about that. Okay, is anything else? Yes, we need to go over this one. Okay, let's go over number 5 here. Okay, so for this one, these are not that bad. All we're going to do here is since this is x minus 1 times x minus 1, or times the quantity x minus 1, I'm sorry, both quantities are, of course, we can just go ahead and take the square root of this side and that side. So to knock that power off, since these are, like I said, since the quantities are the exact same, we can do this. If this were something else, we couldn't do this, of course, but in this case we can. Okay, so this is going to become x minus 1 equals plus or minus square root of 5. So now we want to get this this x by itself by getting rid of the 1. So we can say x minus 1 plus 1 equals 1 plus or minus square root of 5, which leaves us with x equals 1 plus or minus the square root of 5. And in this case, we can leave it written like that, and that's fine. So in your assignment, numbers, let me see here. Numbers 19 through 24, you can write your solutions like that, and that's fine. So these examples will get you through your assignment for today with this method. If you guys have any questions, just let me know.